Hello and welcome to the Developers Forum D3 Part 2. We're just going to do a quick one here now. We're going to do some drawing in the DOM. Last time around we loaded some data, some food, and we just printed out some things on the DOM with that. We created some elements and printed out some text. Now, with D3, we're not going to be printing out text. You could do that with something else. So we're going to be drawn to the DOM and drawing using SVGs. Okay. So we could use what we've done so far to append divs to the DOM and style them like a bar chart, but that would get complicated if we had a lot of data or want to do a complicated graph. Okay, so this is where SVGs come in. SVGs, like we said in the first one, are our canvas. Okay, so we create it first. You can have it in your HTML if you want, or you can create it on the fly with D3. So we'll go back to our code. Okay, so what we're going to do here now, we're going to create an app.js file. We're going to move our code into a separate file instead of coding it directly in the HTML. Okay, that's a bit too large for my liking. So we're going to load D3 and then we're going to load app.js and we'll remove our food. Yeah, I think that's probably a good idea. Okay, so we have a body here and we have a container. So what we're going to do is we're going to go D3. We're going to go var svg is equal to d3 dot select. We're going to use container. We're going to select our container. Instead of appending it to the body, we'll append it to our container. Dot append svg. Okay, simple. Okay, but we have a look at our page now. We do a quick refresh. We explore the elements. We go into our container and we can see our SVG here. It has automatically there, it has a height and a width, 300 by 150, but these are elements we'll want to give it as well. We'll want to control the width and the height of our SVG and of our graph. Okay, you can control pretty much anything about it. Okay, so we have our SVG there. Okay, so doing it the above way creates a variable with a reference to our newly created SVG, allowing easier coding later. Now instead of having to select it each time, we can just use the variable. So we have SVG there available. We don't have to go and look in our DOM every time and select it. We can just use the SVG variable. Okay, it's a good idea on creation of your SVG to give it a width and a height. So you can use the attr function to create attributes or add attributes to your SVG. Okay, so we'll go ahead and we'll do that. So for this selection, we're going to draw a few circles in our graph, just something simple. So we're going to use a simple data set, an array of values for 5, 10, 15, 20, 25. Okay, we're going to say we want our width to be 500 and we want our height to be 400. Okay, then we'll just add in a few items here. attr, so we want width, and I don't know why I put weight. Why did I put weight? It's W. We're just going to change this W and H. Keep it simple. Ah. Okay, and height H. Save this, and we can go back to our page. And we can see our SVG now has a width and a height. Okay, so we can control that part of things. Now we can start drawing. So now we can use our SVG to create elements and pop them into the SVG. So something simple like for our circles. So SVG dot, similar to the last time, dot select all P's. This time around we're using SVG elements. So dot select all circles, dot data set. Then after the dot data function for the number of datum in our data set, the code following dot data will be called. So dot enter and dot append circle. Okay, so we'll go ahead and do that. So we want var circles is equal to SVG. So reference our element above. Dot select all circle. Dot data, pass in our data set. Dot append, dot enter. Dot append. And what are we appending? Circles. Circle. Okay. Does that do anything? We'll have a look. Okay, we have a circle, but we haven't given the circles any attributes. Okay. We've just created a circle element. It doesn't have a width, doesn't have a height, doesn't have a starting point. So a circle has various attributes. Okay, so say, okay, well, yeah. So it has 3 attributes that we need. It has a CX, so a circle X point, it has a CY, a circle Y point, and it has an OR, which is a radius. Okay, so they're the 3 things that place it on the graph and give it a size. So we want to give it a CX. Now we can place it, so okay, so we give circle CX5, CY 10 say, and a radius of 20. Okay, now we've given them X, Y, 20. What happens? Okay, so now we have our circles. We can see we have 1, 2, 3, 4, 5 circles for each data point, but we've drawn them all in the same place. They all have the same coordinates, X and Y, and the same radius. So if we want to change that, we want to change this, so we want to use our data set to place the circles everywhere and use them for the radius. Okay, so we'll, instead of having just a plain figure in there or a number, we'll use a function. Again, we have access within enter, and the functions beyond that, we have access to each datum. So again, it's D. We also have access to the index, which you can call I. Now you can call these things anything you want. They're just placeholders, but common within D3 is to call the datum D and the index I. Okay, so we're going to use our datum and index in our CX attribute. We're going to return. So where do we want it on the X graph? Okay, so we want to start our circles on the left and move them across so they're not on top of each other. So we have our data set with our individual data points, but we also have the index, which 0 to 1, 2, 3, 4, 0 to 4. So if we start on the left, we can use our index as a variable to push them along at a certain distance. So we'll use index, we'll multiply the index by 50 to move them along, and then plus the D value, the value of our datum, multiplied by 2. Okay, we'll have a quick look at this now, see where we go. Now we've moved our circles along a little bit, so the X value you can see here is 10, 70, 130, 150, 250. So 10, where does that CX value come from? Okay, the index in this is 0, so 0 by 50, and then 5 by 2. Same as that. That would be 1 by 50 plus 10 by 2. And on and on. Okay, so we have our circles moving along. Where do we want to place our circles? On the y-axis. Well, up at the top there isn't great, so again we'll run a function. We'll use d, and no, we won't use d. Okay, so we want our circles in the middle of the graph, don't we? That's normally where you'd have something like this. If you have one object or multiple of objects that you just like circles here, you want them in the middle of the graph. So where do we want them? We want to have them in the middle of the graph, so that's simple enough. We do h, which is the height of the graph, and divide it by 2. Refresh our page, and now we have our circles in the middle of the graph. Radius. So we'll go function here again. We'll use our data to describe the circles, or to do something to describe the circles. So the bigger the value, the bigger the circle. So we can return D. See how that looks. Okay, now we have our circles, and we have them drawn on our graph. They relay some information about the data within our data set, and they're spaced across. I wonder if we could do here, we could do width divided by 2 plus, I wonder would that place them in the center of the graph, but it places the first one in the center of the graph and the others run off the page, so maybe not. But within D3 you will find this. There's some messing about with trying to find the ideal placement of where you want your elements in the graph to be, and that's okay. You have access to the datum, you have height, width variables. You can do loads of different things here. You can put padding on them, things like that. Okay, we have other attributes that we can use with our circles. Okay, so we can give them a fill. So we can give them a color, say yellow. We can give them a stroke, say red, and then we can also give them a stroke width, and again bring our data into this so that the colors or the stroke width are telling us about the data as well. So we can do return D divided by 2, say. So we go back to our circles. Now again we have 5 circles, starting from smallest, moving along the page. Color and size, not color, size, showing the difference between the data. We could do color as well. We could change that, so we could do function, go back to our previous example where we're returning RGB and basing that on, so again it was what, between 0 140, say 255, and we want to change one of those based on the data set we're passing in. So we get our expression which will resolve. So our data is between 5 and 25. Our colors run up from 0 to 255. So we can D multiplied by 10. And there we have colors as well coming in, highlighting the different things. So we can use color, size, position, all of these things to draw on the DOM. And you can see down below here we have our SVG, we have our circles within that. They all have attributes that are being added by D3. We can change the fill as well. We'll add in another function. And again, similar. Return RGB. This time around we'll the first one can be the value. So D multiplied by 10. Is that all good? Nope, that's not all good. No, it's all good. And again, we're introducing color or changing color depending on our data. Okay. Scales don't come into what we're doing today. We're doing a D3 tree graph, and scales come into bar graphs more often or not. We don't have a scatter plot example either, but just scales. So scales are functions that map from an input domain to an output range. Okay, chances are your data isn't going to match the pixel dimensions of your graph. So we had a 500 by 400 graph. Your data is not going to be restrained by those values. Your data is not going to go from 0 to 500. Chances are that's not going to happen. So scales provide a convenient way to map your data to new values for the purposes of your visualization. Okay, so D3 scales are functions with parameters that you define. Once created, you call the scale function, pass it a data value, and it returns a scaled output that is relevant for your graph. So you have an input, your data, you process it with a function, and you output a new value that is relevant to your graph. A scale itself has no direct visual output. It's a mathematical relationship, taking your data and redefining it in useful terms for your graph. Okay, so a scale's input domain is the range of possible input data values. A scale output range is the range of possible output values. Given the data that you might have, so say if you have a domain between 0 and 500 and you have, this example is, say if you have a domain looking at the graph here, say if you have a domain of between 20 and 80. All your data points are between values between 20 and 80. Your graph has 0 between 0 and 120. So we define a scale, we pass that in our domain, we pass in our range, and then we can call that function, passing it a value, and it will match up a relevant value for our graph. Okay, there are loads of functions, there are loads of scales, there are linear scales, there are log scales, plenty of scales within D3. There are also D3 min and D3.max. So in terms of your data, if you don't know what your min and your max are in your data set, you can use D3 methods to find these out to pass it into your scale function. Okay, so putting it all together, if you create another scale, D3.scale linear, pass in your domain, it starts at 0, and then you get your max function. So D3.max, you pass in your data set, and you return the lowest value, or you return D0. Okay, and then the range, you pass in 0, and then the width of your graph. So you use abstract functions here to max out your data and your graph. That's it for today's lesson. Tomorrow, or next lesson, we are going to be running through a tree graph. So this is what we're looking to build, an interactive tree graph that has parents and children, and you can click on. Okay, thank you very much.